Hi guys, I'm back after a long break. I actually had exams for some time, went on a vacation, now I'm back. Hopefully I'm gonna solve more papers this year. So today we're gonna start with this paper. This is 9702, paper 1 to February March 2023. The time is 1 hour 15 minutes. Please do drop question paper requests down in the comments below. I'm gonna try to solve more paper 1, paper 4, and 5 this year. Hopefully I can do more math. Um, there was, some actions taken by Cambridge, I guess, against some channels for publishing papers that have not released yet, which is why I was not uploading papers for quite some time. That was also another reason. Hopefully, I'm going to be uploading every week now. Also, please remember to subscribe to the channel if you like the content, like the video, helps with the algorithm a lot. And I'm glad to say that I've also launched the Patreon for my channel. So if you like to support me, please do become a patron. It's patreon.com/CAIE papers solved. I'll put a link in the description. There are 3 tiers, by the way. The first one is just for support. The second one is for special notes prepared by me and paper solving requests. You also get ad-free videos and special fan requests. And the $15 tier is for the ultimate learning experience, where you also get access to phone calls and video meetings with me, where we can go through all your problems. All right. So yeah, please do check those out if you do need extra help, and please subscribe to the channel. So let's begin without further ado. Before we begin, I'd like to talk about the threshold. So for this paper, the full marks is 30, we do know that. So a star, sorry, it is 40, my bad, it's 40. And A was at 28, B was at 25, C was at 21, D was at 18, and E was at 15. So A star was probably at around 31 to 32, probably, yeah, or a bit higher. So let's begin. What represents a physical quantity? We know that a physical quantity has two components, a numerical value as well as a unit. A does not have a unit, it has a value though. B is just a unit, no value. C is the correct answer because we have a value, 7 newtons, as well as the unit newtons. The relationship between the variables d and t is given by this equation, where b and c are constants. The unit of d is meter square and the unit of t is seconds. What are the units of b and c? So 1 by time, the unit is second to the power minus 1. So b divided by root d plus c should also be equal to second to the power minus 1. So the unit of d is meter square. So this is basically b divided by root over meter square plus c, which is b divided by meter plus c. So essentially, I want to get rid of the meter, right? So look, a is invalid because, look at this. If I do write it meter per second by meter plus second, we can get rid of the meters, but the net answer becomes 2 seconds. But I am looking for second to the power minus 1, so A is not the correct answer. If I go for B, it is meter per second divided by meter plus second to the power minus 1. We get rid of this, so yeah, we do get the correct unit, second to the power minus 1. So B looks like the answer. C and D are wrong because if you wrote meter to the power minus 1 second by meter plus second. It would actually turn into meter to the power minus 2 second plus second, which doesn't make sense. So yeah, 2 is wrong. Moving on. 3, a hollow cylinder which is open at both ends has a radius of 3 and a length of 15. What is the value with absolute uncertainty of the surface area? So it's hollow. It's hollow, so both the top and bottom, there is nothing here, neither anything here. So we just have the curved surface. So what is the formula for the total surface area here? Curved surface is just going to be 2 pi rh. So 2 into pi into 3 into 15. 2 into pi into 3 into 15, that is 90 pi or 282.74, okay, centimeter square. Now I want to find out the uncertainty. So 2 pi, these are constants, so the uncertainty in TSA by the value itself, 282.74, is equal to del r by r plus del h by h, which actually results in, 0.1 by 3 plus 0.1 by 15 times 282.74 del TSA. How much is that? Let's see. So 18 by 5 pi or 11.3. So we know that uncertainty can be given to one significant figure only. So if we round this off to 1SF, it is 10. So the correct answer should be 280 plus minus 10. I'm going to go with A. That is the correct answer. 4. A snooker ball of mass 0.2 kg has a collision so that its direction of movement changes by an angle of 90 degrees as shown. Interesting. The ball has a speed of 0.40 meters per second before the collision and a speed of 0.30 meters per second after the collision. What is the magnitude of the change in momentum of the snooker ball? So basically, before the collision, we were moving like this, and after the collision, we move like this upwards. So basically, this purple one is the resultant, right? This purple one is the resultant one. Now, we basically need to find out the magnitude of the change in momentum of the snooker ball. So guys, if this was our initial motion, obviously we need another vector to end up at this point. So what is that vector? What can that vector be? This one over here. In that way, we can end up at the purple point, right? There's no other way that we go vertically upwards. Because that's our resultant one, so it's the summation of these two. So let's try to figure it out. Now, the arrows I've drawn here are a bit weird, because check this. Why don't I draw the diagram this way? The one over here, the one below. Essentially, we were moving like this, and somehow we move vertically upwards. Our end result is here. Always remember that the head of one arrow must bind to the tail of another arrow. Okay, the head of one arrow must bind to the tail of another one. So the head of the blue arrow must, join with the tail of another one. So if you do draw a vector like this, that is the only way we get our resultant vector as the one that is vertical upwards. So we have a mass of 0.2. So what is it? 0.30 times 0.2. This is my resultant one. And my initial one was 0.40 times 0.20. So this momentum over here is unknown. It's honestly the same diagram as the one I drew before, but this is just more accurate. Okay, you'd get same answer. Okay, but it's just that this is the correct way to draw it. So we can just use Pythagoras theorem, right? So p square is equal to zero point 0.3 times zero point 0.2 whole square plus zero point 0.4 times zero point 0.2 whole square. So if you do the math, you're going to get an answer of 0.1. So 4 happens to be B. See if this makes sense. A momentum is indeed a vector quantity. Also, a lot of students have been requesting online tuition. I do teach here in Bangladesh, both online and offline. But it's like sometimes I do use my native language here as well, so a lot of international students wouldn't get it. So if you guys are interested, I might open an online batch for you guys. So yeah, if you are, please comment down below, and I can give you the details, and we can start soon maybe. So only for physics, chemistry, and math though. We can just solve question papers in class. So yeah, if you're interested, please do comment down below. And you also have access to, video meetings on my Patreon, so you can sign up for that as well. For 5, a ball is kicked upwards at an angle of 45 degrees to horizontal ground. After a short flight, the ball returns to the ground. It may be assumed that air resistance is negligible. What is never zero during the flight of the ball? Okay, so this is horizontal ground. A ball is kicked up like this at an angle of 45 degrees. Okay, now after a short flight, the ball returns to the ground. So essentially, the path was like this. It was a projectile. So what was never zero? The horizontal component of the ball's acceleration. This was always zero. Okay, it can't be a because the ball, since there is no resistance, the ball only experiences weight. So there is no horizontal force. So horizontal acceleration is always zero. However, the horizontal component of the ball's velocity, there is always a component, right? Basically, v cos 45 degrees, it always exists. It never changes because there is no horizontal force. Yep. So yeah, that's all. That is it. Never changes. The vertical component of the ball's momentum and velocity do change though, because at this point, at the topmost point, the ball has no vertical velocity. The graph shows the variation with time t of the displacement s of an object, which graph represents the variation of time with time t of the acceleration of the object. So guys, remember that the gradient of the displacement time graph is in fact velocity. So if I drew another graph, so in this section the gradient is constant, so the graph of velocity is going to be like this. We are going to have a positive constant value, and then we have a negative constant value, same magnitude. Wait, I think I drew too much. Yeah, check this. So for the first section we have a positive value like this, then we have a negative value, then we again have the same positive value again, right? And then we have the same negative value again. Okay, so this is the velocity time graph. Now the gradient of the velocity time graph is acceleration. So if you draw that graph for acceleration, you are going to get something like this. So you have no acceleration here because velocity is constant, so acceleration is 0 over here, but suddenly the velocity decreases, so we are gonna have deceleration over here suddenly for like one split second, and then it's gonna remain 0 again, and then for one split second over here velocity suddenly increases, so we're gonna have acceleration over there again, and then it comes to 0 again in this section, 0 again, and then again deceleration because velocity suddenly decreases, and then straight line again because there is no change in velocity. So the correct graph is in fact D. See how it changes. Differentiate this, you get this, and after differentiation of this you get this one. Okay, which expression defines force? So guys, force is defined as the rate of change of momentum, okay? It is given in the syllabus, which is why the answer is D. A ship of mass 8.4 into 10 power 7 kg is approaching a harbor with speed 16.4 meter per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 newtons. How long will it take to stop? Interesting. So, this is the force, and we know that F is equal to del P by T. So, we want to find out the time it takes for, you know, this whole momentum to decrease to zero. So, what's our current momentum? It is 16.4 times the mass, 8.4 into 10 power 7. I want to decrease it to 0, and the braking force is 920,000. So let's try using this formula. 16.4 times 8.4 into 10 to the power 7. So answer divided by 920,000. That gives you an answer of 1497 approx seconds. So if you divide that by 60, I'm getting an answer of 24.9 or 25, 24.96, so 25. Okay, 25 minutes, that is C. Now in the velocity time graphs of 4 different objects are shown. Which graph represents an object falling from rest through a long distance in the Earth's atmosphere? Okay, so if you are traveling in the atmosphere, so obviously you will feel air resistance. So essentially over time we will reach terminal velocity. Not immediately, but over time. Initially, you will accelerate and then reach terminal velocity, which is why D is the correct answer. Velocity increases over time, but at one point reaches terminal velocity. Yeah? Which statement about collisions is correct? Kinetic energy is conserved in all collisions. Not always, only in elastic ones. So A is incorrect. Momentum is only conserved in perfectly elastic. Wrong. It is conserved in both types of collisions. The relative speed of approach is equal to the relative speed of separation for perfectly elastic collisions. That is perfect. D is wrong, guys. According to Newton's third law, this exact the same force exerts. Sorry. Number 11. A satellite uses two thrusters to adjust its motion in space. Each thruster exerts a force of 40 newtons on the satellite. The line of action of each force is a perpendicular distance of 2.3 meters from the center of gravity of the satellite. These two parallel forces act in opposite directions. Okay, so this is essentially a couple, force of the same magnitude acting in opposite directions but providing the same type of moment. So if you want to find the net moment or the torque, it's just going to be the total distance between them multiplied by one of the forces. So 40 times 2.3 is the torque. Sorry, 40 times the total distance, which is 2.3 times 2, 4.6. 4.6 times 40, that gives you 184. So the closest answer is 180. So it's between these two. But what is the resultant force? Upwards 40, downwards 40. The net force is in fact 0. So it's C. 11 is C. This is a question on a couple. Relatively easy till now. I haven't seen a hard question yet. Let's move on to the next one. The diagram shows two ways of hanging the same picture. Guys, this is a common question. I've seen this in previous years. In both cases, a string is attached to the same points on the picture and looped symmetrically over a nail in a wall. The forces shown are those that act on the nail. In diagram 1, the string loop is shorter than in diagram 2. Which information about the magnitude of the forces is correct? Okay, so let's do this, guys, step by step. Okay, so in both cases, what's happening actually, um, we are hanging the same picture, so the weight of the picture is actually remaining the same. The forces shown are those that act on the nail. In diagram 1, the string loop is shorter than in diagram 2. Okay, the string loop, this loop is shorter. So basically R1 is, balancing the weight of the picture as well as, balancing those the forces of tension. Essentially R1 and R2 need to have the same value for each question over here for sure. Let me read this question again. Yeah, it is correct. Basically, due to the weight of the picture, the nail over there is actually balancing the reaction. The R of the force R1 is balancing the weight of the picture. So since the weight isn't changing, so R1 and R2 shouldn't change. That's why C and D are excluded. And we need to find out what actually happens to T1 and T2. Okay, so check this out. Over here, what happened to the angle? Let's call this alpha, and let's call this beta. Alpha is bigger than beta. Obviously, the components, the horizontal components of T1 and T2 balance each other out. Like T2 sine beta is equal to T2 sine beta on the other side as well. Similarly, T1 cos alpha, T1 sine alpha is equal to T1 sine alpha on the other side as well. Now, what about the cos angle though? Do you guys know the graph of cos actually? Cos x. So it's like this. It begins at +1. It goes like this here. So how does cos behave? Cos 0 is 1. You guys need to remember that. Cos 0 is in fact 1. And cos 90 is actually 0. So cos 0 is 1 and cos 90 is 0, as you can see on the graph. So as you go from cos 0 to 90, you're actually going from 1 to 0 essentially. So for example, I'm just going to use a hypothetical angle. What if this was 45 degree and what if this was 30 degree because it's smaller? So just try it in the calculator. Use cos 45 degree. The value cos 45 degree is actually 0.71. On the other hand, cos 30 is equal to 0.87. So as we decrease the acute angle, what's actually happening? The value of cos is increasing. So in this specific diagram, T2 cos beta, T2 cos beta has a higher value than T1 cos alpha, right? Clearly, because cos 30 is higher than cos 45. So let's do the math over here. R1 is actually equal to the summation of T1 cos alpha times 2. It's 2 times T1 cos alpha. On the other hand, on this picture on the right, R2 is equal to 2 times T2 cos beta. And we know that R1 is equal to R2. So we can actually equate these parts of the equation. This part is equal to the one on the right hand side. So can we not write that, T1 cos alpha is equal to T2 cos beta? We can, right? Now let's input the values over here. Since it's in equilibrium, since the whole picture is in equilibrium, that means the net force must be 0. Okay, and about the weight of the picture, there is it is balanced over there, but when we consider the nail only, we're going to consider the forces R1, T1 and T1, for example. So now let's try to input this. So T1 times cos 45 is equal to T2 cos 30 degree. So let's do the math. T1 is equal to T2 times cos 30 by cos 45. Cos 30 divided by cos 45. Let's see what we get. T1 is equal to 1.22 times T2. So yeah, T1 is in fact greater than T2. That is why B is the correct answer. The vertical upward force cannot change because it is ultimately balancing the weight of the painting, But the but the but T1 and T2 can change because you're changing the angle. Okay. So yeah, in fact, when you do use a smaller angle, there is less tension in the string. That's the essential logic. Okay. So there's less chance of it, you know, getting cut down or tearing apart. All right. And since it's hanging, it's in equilibrium. Moving on to question number 13. An object shaped as a hemisphere rests with its flat surface on a table. The object has radius r and density rho. The volume is this. Which average pressure does the object exert? So this is actually a hemisphere. So what's the volume of a hemisphere? It is basically 2 by 3 pi r cube. Half of this. Now we know that pressure is equal to force by area. So for the hemisphere, if we cut it, what's it exerting? Which surface is on the table? This circle basically, right? So the area for a circle is actually pi r square, and we know that density is equal to mass by volume. So mass equals to density into volume, and we also know that W is equal to mg. So on the top, can we write mass is basically the force, or the weight is actually the mass into g, or P is equal to density into volume into g divided by pi r square. Let's solve this. So P is equal to density rho, volume is 2 by 3 pi r cube, g is g divided by pi r square. Let's get rid of some of the stuff. We can get rid of pi, we can get rid of this, so we actually end up with P is equal to 2 by 3 rho rg, 2 by 3 rho rg. 2 by 3 rho rg. So I'm gonna go with 13D, and that is in fact the correct answer. Okay, that's how you do it. A probe is used to monitor the quality of water in the sea. The probe is suspended by a vertical string which is attached to a sphere. The stationary sphere floats in equilibrium on the surface of the sea as shown. So it's floating in equilibrium. The sphere has a weight of 5 Newton. The probe and string have a combined weight of 2 Newton. The density of seawater is this. The upthrust acting on the probe and thread is negligible. Okay, so we do not consider that upthrust. What is the volume of the sphere below the surface of the sea? So guys, only the part that is immersed will experience upthrust actually. So let's see. So since it's in equilibrium, upthrust is equal to weight. So what's the formula of upthrust? V rho g is equal to weight of them combined. The sphere has a weight of 5, we take the whole one, and the probe and string have a weight of 2. And this is the density. So in V rho g, V is the volume of sphere that is immersed, rho is the density of the fluid in which it is immersed, g is 9.81, and on weight we have all the downward forces on the right hand side. So the answer is 7 divided by 9.81 times 1.03 into 10 to the power 3. I get an answer of V is equal to 6.93 into 10 to the power minus 4. Do we have that? We do. So 14 is D. What is the center of gravity of the object? So according to the syllabus, it is defined as the point at which all the weight of the object may be considered to be acted. That is the definition. A system with an efficiency of 74% wastes this much power. Okay, so we know that efficiency is equal to useful power output divided by total input times 100. Okay, so we know that the efficiency is 74%. So the wastage is 230. So how can you find out total power wasted? So total input is equal to wasted power plus useful power. Okay, so we know that total is equal to 230 plus useful. So we need the useful output power. So can I write this, that useful divided by total, which is, useful plus 230 is equal to 74 by 100. So let's do the math. I'm going to write it as u times 100 is equal to 74u plus 230 times 74, which is 17020. So 100 minus 74, 26u is equal to 17020. So 17020 by answer, that gives you 654. 654.6 watts. So which is the closest answer, guys? 16 is C. That's good, that's good. Let's move on to the next one. Okay. For 17, let's read the question. What do we have? A projectile of mass 0.25 kg is at a height of 30 meters above horizontal ground. Interesting. Now, basically, it is traveling at a speed of 15 meters per second. A short time later, it is at a height of 35 meters above the horizontal ground and traveling at a speed of 5 meters per second. How much work is done against air resistance during this time? So we need to do this using energy. So let me show you how it's done. So initially, we are 30 meters above ground. We are traveling up at a speed of 15, and then sometime later we are at a height of 35 meters, but now we have a speed of 5. So what's the energy conversion? Initially we have some ke, so which is half. Initial k is equal to half into m into u square. We have some gp, which is mgh, is equal to, finally we also have some kinetic energy, half mv square, as well as some mgh, but we have also done some work done. We have some work done against resistance, which we specifically need to find out. So initial ke plus initial gp is equal to final ke plus final gp plus work done against resistance. Let's do it. So initial k, half into 0.25 into 15 square plus mgh, 0.25 into 9.81 into 30 is equal to half into 0.25 into 5 square final k plus some mgh, 0.25 into 9.81 into the height of 35 plus the work done against resistance. I want to find that out. Let's do this. So 0.5 times 0.25 into 15 square minus 0.25 into 9.81 into 30 minus 0.5 into 0.25 into okay 0.25 into 9.81 times 35. I'm getting a value of 12.7. Let's see if that's in the mark scheme. So yeah, the closest answer is 17b. Correct. 13. A spring has an unstretched length of 4.5. The spring is fixed at one end, and a force of 35 Newton is applied to the other end so that the spring extends. The spring obeys Hooke's law, and the spring constant is 420. What is the strain of this extended spring? Strain epsilon is denoted as extension by original length. So let's find out the extension. We know that F equals to kx, so x is equal to 35 by 420, which is 0.08333. So let's find out the strain now. So 0.08333 divided by unstretched length. This is in centimeters though, so we need to convert it into meters. 4.50 into 10 to the power minus 2. Let's do that. 4.5 times 10 to the power minus 2. I'm getting 1.85. One. Is that even possible? Okay. Basically, yeah, if you convert this to centimeters, it is, 8.33. So it seems like our extension is actually greater than the original length of the spring. That's crazy, guys. So 1.85. Usually you don't get this type of sum. A wire is fixed at one end and extended by a force that is applied to the other end. The force is slowly increased from zero and then slowly decreased back to zero. The force extension graph of the wire is shown. Since we do come back to our original position, that means that the elastic limit hasn't been crossed. Yes, we have crossed the limit of proportionality, but the elastic limit hasn't been crossed yet because we come back to our original position. So it is not plastic. Okay, it is elastic because we are able to come back to our original position. Waves. In a progressive water wave, two particles P and Q on the surface of the water are fixed horizontal distance apart. P and Q oscillate vertically. By the way, about the Major 23 papers, they will be out on August 11th. I'll solve them afterwards. At time t is equal to 0, the wave is shown as shown. Which graph best represents where the variation with t of the phase difference between the oscillation of water particle P and the oscillation of particle Q. Okay, so guys, check this out. The phase difference between these two particles. This was a trick question. They are not asking you the movement of one particle. Could I clarify? Because if they ask you the movement of particle P, it would have been like this, P is already at the highest point, right? So its displacement would have been like this for P. On the other hand, Q is already at the midpoint, right? And at this moment it is moving downwards, so it would start from 0 and it would move downwards like this. That's it for Q. But here they're just asking the phase difference. So honestly, look at the phase difference. If you find out the angle, what is it? It's like 270 degrees, and it will be constant at 270 degrees. It's never gonna change. Okay, so that was the trick question. So honestly, 20 is gonna be D. It's the first time I've seen this question. If they ask you the phase difference between 2 points, there's no way that it's gonna change. All right. Which statement about longitudinal and transverse waves is not correct? Both waves can be polarized. We have our answer, guys. Only transverse waves can be polarized. Longitudinal waves cannot be polarized. An observer hears a sound wave emitted from a moving source. The observed frequency is less than the frequency of sound emitted from the source. What could be the reason for this? Okay, so if the observed frequency is less than the frequency of sound emitted from the source, there are two scenarios actually. If an object comes towards you, frequency increases, and if the object goes away from you, frequency decreases. So when does frequency decrease? When the source moves away from the observer. So clearly the answer is A. There is another case where this might occur. It might be when the source is moving towards the observer but decelerating. That's also another scenario. Okay. What is the approximate range of electromagnetic radiation visible to the human eye? So visible light, it's approx 400 to 700 nanometers, which is 400 to 700 into 10 to the power minus 9, which is 4 to 7 into 10 to the power minus 7, right? Meters. So let's convert each of these and find out. So 430 into 10 to the power 3, how much is that? 430 to 750 into 10 to the power 3, which is 4.3 to 7.5 into 10 to the power 5. Wrong, can't be A. For B it's 430 to 750 into 10 to the power 6, which is 4.3 into 10 to the power 128. Impossible. It should be minus 7. Oh, this is the frequency, right? Sorry, I messed up. Basically, I wrote the wavelength. My bad. I wrote the wavelength. I need to convert this to I wrote the wavelength. I need to convert it to frequency. My bad. So why don't I just take a middle value? I can take 500 nanometers. We know that the speed of light in vacuum is 3 into 10 power 8, v equals to f lambda. 3 into 10 to the power 8 equals to the frequency times 500 into 10 to the power minus 9. Let's do this. So 3 into 10 to the power 8 divided by 500 into 10 to the power minus 9. This gives you a value of 6 times 10 to the power 14. This is what I'm looking for, 6 times 10 to the power 14. So A and B are both wrong. 430 into 10 to the power 9, which is 4.3 into 10 to the power 11, still wrong. It needs to be D, guys, come on. 4.3, so 430 times 10 to the power 12, which is 4.3 times 10 to the power 14. Perfect, it falls in the range. 24, polarization has been added to the syllabus in 2022. A beam of vertically polarized light is incident normally on a polarizing filter. The filter can be rotated so that it is always in a plane perpendicular to the beam. The transmission axis of the filter is initially vertical. The filter is first rotated clockwise by an angle of 30 degrees so that the transmitted light waves have intensity 30. The filter is then rotated clockwise by a further angle of 30 degrees. What is the new intensity of the transmitted light waves? Interesting. So guys, initially, suppose, let me draw a picture for you guys, okay? How are these drawn again? I actually forgot how to draw them. It's been a long time. Wait, let me check. I just need a picture. Wait, I think I can draw one still. So for example, if this is your plane polarized light, vertical, this was initially vertical. And yeah, this is our filter. The transmission axis was initially vertical, but now it has been rotated by 30 degrees. As a result, we know that the formula is I is equal to I naught cos square theta. So the first one is actually I naught cos 30 square, which is 3/4. I is equal to 3/4 of I naught. So what they meant to say here is that I30 is actually 3/4 of I. Okay, now we rotate this thing a further 30 degree, a further of 30 degrees. So now it's actually at 60 degrees. It's at 60 degrees right now. So if you do the math, I is equal to I naught cos 60 square, cos square 60, cos 60 square, it turns into 1/4. So I is equal to 1/4 of I naught. But here, listen to the question carefully. It's a bit complicated. Let's try to read it again. The filter is first rotated clockwise by an angle of 30 degrees so that the transmitted light waves have intensity I30. Then it is rotated clockwise by a further angle of 30 degrees. What is the new intensity of the transmitted light waves? So after we rotated the second time, compared to the initial one, it is 1/4 of the original value. Do you guys understand? 1/4 of the initial value. But we are actually comparing this last one over here with the second one. So if you do that, come on, check this. This is the second one and this is the third one, and I naught was the first one, initial one, without any polarization, without passing through the filter, my bad. So we have to find this out in terms of I30, right? So how do we do this actually? What's the correct way? What is the new intensity of the transmitted light waves in terms of I30? So the new one, the last one, is I is equal to 1/4 of I naught. Can we not do this? Can we not make I naught the subject? We can. I naught is equal to 4 by 3 I30. Then I'm gonna substitute this over here. We know that the final intensity final is equal to 1 by 4 I naught. So we end up with 1 by 4 times 4 by 3 I30. And the final answer is 1 by 3, 1/3 of I30, and that is why I'm gonna go with B. Interesting question. I haven't seen this. This was quite tough, guys. They're evolving the questions, so be careful. 25. Common question. A musical instrument is made using a long tube with a mouthpiece at one end. The other end is open and flared. A musician maintains stationary waves with a node at the mouthpiece, node over here, and an anti-node at the other end. Okay, so the first pattern can be like this, then consecutively the patterns can be like this, then you can get something like, you know, 2 loops, and then something like this. Okay, that's how it goes. Now, which different frequencies of sounds can be produced by the instrument? Guys, this is something that you can memorize if you want. It occurs, the series is like this: F naught, 3 F naught, 5 F naught, 7 F naught. That's how it goes. So if this is F naught, this is gonna be 3 F naught, this is gonna be 5 F naught. That's just the series for antinode on one end and node on the other one. So let's just check. 92 times 3 is 276. So clearly we have answers between this. 92 times 5 is 460. So clearly this is excluded. That's why I'm gonna go with 25C. See, it matches this series. Then try 7 F naught, 7 into 92, that's 644, easy as that. And if you had a node at each end or antinode at each end, that's just F naught, 2 F naught, 3 F naught, 4 F naught, all integers basically. Two waves of equal frequency and amplitude are traveling in opposite directions along a stretched string. When they meet, they form a station wave with 3 nodes and 2 antinodes. So initially we have this pattern with 3 nodes and 2 antinodes. We have this pattern. Okay, node, 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 antinode, antinode. The frequency of both waves is doubled and a new stationary wave is formed. Interesting. How many antinodes are there in the new one? So I just told you, according to the last one, if you have 2 nodes at the end, right? This is the pattern. So if you think about it, which pattern does this one correspond with? It corresponds with this. So what will the pattern for F naught be? It should be like this, you know, nodes at 2 ends and an antinode in the middle. This is the pattern for this one. So if we double this frequency, this is already at 2 F naught. If we double this frequency to 4 F naught, what will the pattern be? Since I've doubled it, basically 4 loops: 1, 2, 3, 4. So in total 1, 2, 3, 4, 5 nodes, and 1, 2, 3, 4, 4 antinodes. I'm gonna go with 26D. See, easy. Next, a transmitting mast sends out microwaves of wavelength 1.5 centimeter and radio waves of wavelength 1.5 km. A receiving aerial behind a mountain can detect the radio waves but not the microwaves. Oh, okay. So guys, remember, for mountains we need to diffract the waves, so that spread the waves so that it can hit the other side. So remember, the greater the wavelength, the better the diffraction, essentially. So radio waves, you know that it's GXUVIMR. Radio has greater wavelength than micros, so it can be diffracted more easily. So the answer is basically B, because radio waves have a bigger wavelength. They can be diffracted easily around the mountain, but why microwaves cannot? That's why we use radio waves for telecommunication and stuff. Waves are emitted from two coherent sources. Which statement about the waves must be correct? So just because you're coherent doesn't mean you are in phase. You can, be out of phase. Like two coherent waves. What is the definition of coherent? Having constant phase difference. Like it doesn't have to be 0 or 360-degree. It can be 30-degree. It can be 180-degree. You can have any angle as long as it's constant. Okay. The diagram shows a screen that is a distance L from a diffraction grating. The grating has a total number of n lines. Any two adjacent lines are distance d apart. A beam of parallel light of wavelength lambda is incident normally on the grating. Okay. Which quantities affect the distance between the first order maxima on the screen? This one. This distance. So we know that d sine theta is equal to n lambda. So honestly speaking, we can find this is theta, right? This is theta over here. Which quantities affect the distance between the first order maxima? So sine theta is equal to n lambda by d. Small n will be kept constant, okay? Because we are dealing with the first order maxima. So we are mainly dealing with theta over here. This distance L, number of lines in the grating, and distance d. So guys, if you change distance d, obviously theta will change. And think about it, if theta changes, like if theta was larger, wouldn't the first orders be further apart? So obviously, since theta depends on d and theta changes L over here, since theta changes L, that's why d must have a significance. Similarly, we know that the formula for d is 1 by capital N. So since d depends on capital N, you know, like basically, like what is capital N, to be honest? It's a number of lines per meter. Is a number of lines per meter. However, in this particular question, look at what n represents. The grating has a total number of n lines. So honestly, the total number of lines does not matter. It's the number of lines per meter that matters. That is the n I'm talking about. But here n happens to have a separate meaning, which is why n does not contribute. So it's not going to be C or D. It's going to be between A and B. So since d determines theta and theta determines L, d is correct. Let's look at lambda. Lambda also affects theta, right? Which is why lambda is also correct. And check out distance L. Thing is, usually L doesn't matter, but in this particular question, think about it. If you increased distance L, check this out. So the screen would be further, and look at this. The first order maximas, maybe it wouldn't affect the angle would have remained the same, but check their distance apart, it does increase. So L does play a role. So all these three play a role, but N doesn't play a role specifically because it says that N is the total number of lines. They just tricked you. I've never seen this question before, guys. This is rather hard. A lot of candidates would have made a mistake. Hell, even I would have made a mistake, maybe. It's a bit tricky because I would have thought that n was, d is equal to 1 by n, that n, number of lines per meter, but n is the total number of lines. A wire carries a current of 0.1 microamps. The potential difference across the wire is 10 millivolt. How much energy is dissipated by the wire at a time of 10 seconds? Okay, pretty simple. We know that voltage equals to work done by charge, or work done electrical energy equals to VQ, and Q is equal to IT. So let's do this. Voltage 10 into 10 to the power minus 3 times IT, 0.10 into 10 to the power minus 6, that's the current, and time is 10 seconds. Multiply this. 10 into 10 to the power minus 3 into 0.1 into 10 to the power minus 6 into 10. This gives you a value of 1 into 10 to the power minus 8 joules. 1 into 10 to the power minus 8 joules. Now you convert it to nano and pico. If you convert it to nano, it is 1 into 10 to the power minus 8 times 10 to the power 9. It is actually 10 nanometers. Nanojoules, sorry. So yeah, D looks like the correct answer. Last 10 MCQs then. What is the definition of potential difference? I just told you V is the work done per unit charge, or the energy transferred per unit charge, which is why 31 is A. Which graph represents a filament lamp? So the IV characteristic of a filament lamp is like this. So we are gonna go with option B. The table shows the properties of two different wires. Wire P is the cross section of diameter D. And what is the diameter of the cross section of wire Q? Okay, so we know that R is equal to rho L by A, or R is equal to rho L by pi D square by 4. So R is equal to rho times L times 4 divided by pi D square. So this is the data for wire P. Resistance of P is 4 rho L by pi D square. 4 rho L by pi D square. 4 rho L by pi D square. Okay, 4 rho L by pi D square. Now, wire Q, we have to find the diameter of wire Q. So let's do that. Oh, this is denoted as R. So now for wire Q, the resistance is in fact 1 by 4R. It's 1/4 of this essentially. So let's find out the resistance of wire Q first. So rho L by A, if I input the data properly, rho R resistance of Q is equal to rho, which is 1/3 of rho times L, which is twice L, divided by pi into D square by 4. But let's call this D as capital D, then it will be easier for us to, work things around. Pi D square by 4. So after simplification, RQ comes out as 4 times 2 is 8. So 8 by 3 rho L by D square. And this value over here, right, RQ, we know that RQ is 1/4 of RP. Okay, so using this relation, I'm going to equate my two values, R and this RQ. Are we clear? So let's do this. We can write 8 by 3 into rho L by D square is equal to 1/4 of, I need more space, honestly, I need more space. Wait. So yeah, 8 by 3 rho L D square is equal to 1/4 of 4 rho L by pi D square. Now let's do this. We can get rid of these 4's. We can get rid of the rho and L. So we actually get 8 by 3 D square is equal to 1 by, oh, where did my pi go? Here, the pi should be here. We can also get rid of this pi over here on both sides. So 8 by 3 D square is equal to 1 by D square. So D square, small d square, if I cross multiply, 8 small d square is equal to 3 capital D square, or capital D square is equal to 8 by 3 small d square, root over answer on that side, root over 8 by 3 gives you a value of 1.63 times D. Do we have that as an answer? We actually do. 33 is B. So the working for this was rather complicated, quite hard. I'll go through it again. Basically, I found out R using this set of data, rho L, and I kept the diameter as D for RP. And then I found out RQ using this data, 1 by 3 rho and 2L. I kept the diameter as capital D. Then I used this relation that RQ is actually 1/4 of RP. That way I found out the final answer. A cell has a constant electromotive force. A variable resistor is connected between the terminals of the cell. The resistance of the variable resistor is decreased. Which statement about the change of the cell's terminal PD is correct? Okay. So essentially we have a battery. It's not stated, but it's implied that we do have internal resistance, and we have a variable resistor over here. So if you decrease the resistance of this, the current in the circuit actually increases, and as a result the lost volts will increase and terminal PD will actually decrease. So the terminal PD is decreased, not increased. The terminal PD is decreased because more work is done moving unit charge through the internal resistance of the cell. The terminal PD is decreased because the current in the variable resistor is decreased. B is wrong, right? So it has to be A. 34 is A. Kirchhoff's two laws for electric circuits can be derived by using conservation laws. So remember, first law, the sum of current passing into a junction is equal to sum of current leaving the junction, and it follows the law of conservation of charge. Okay. The second law, the sum of EMF in a loop equals to the sum of PD in a loop. It follows the law of conservation of energy. So 35 is in fact B. A battery of electromotive force 10 volts and internal resistance R is connected to three resistors of resistances R, 2 ohms and 15 ohms as shown. A current of 0.45 amps is in the resistor of resistance 2 ohms, and a current of 0.48 amps is in the resistor of resistance 15 ohms. What are the values of small r and capital R? Let's do this, guys. So let's find out the voltage here. 0.48 times 15, that should be 7.2. So these two combined should also have a value of 7.2. So we can write 0.45 times 2 plus 0.45 times R is actually equal to 7.2. So 0.45 times 2, I know I can take 0.45 common. So 0.9 is equal to, sorry, 0.9 plus 0.45 R is equal to 7.2. 7.2 minus 0.9 divided by 0.45 gives me a value of R is equal to 14, a whopping 14. So it's between 14 for sure. Next, since these guys are taking 7.2, what's small r taking? 10 minus 7.2, that's 2.8 volts. And one other thing, we know the sum of current entering a junction equals to sum of current leaving. So the total current in the circuit is 0.45 plus 0.48. 0.45 plus 0.48. I used these values, 0.45 and 0.48, 0.93. So let's find out the voltage, the lost volts. It's 0.93. Sorry, we have the lost volts. It is 2.8 volts. And we know that V equals to IR. So 2.8 is equal to 0.93 current times resistance, smaller. So 2.8 divided by 0.93 gives you a value of 3.01. So the closest answer is 3. So I'm going to go for 36A. Perfect. 37. A battery of negligible internal resistance is connected in series with a thermistor and a fixed resistor of resistance 12 kilo ohms as shown. The table shows the resistance of thermistor at two different temperatures. Okay, so the potential difference V out across the fixed resistor is 4.50 when the thermistor is set at 20 degrees. When this also has 12 kilo ohms. What is the EMF? We don't have that. So this is the three-coin tap line. The fixed resistor has uh, resistance of 12 kilo ohm. So when the thermistor is also at 12 kilo ohm, you know, since both of them have the same resistance, this will also have a voltage of 4.5. So we found out the EMF of the battery is actually 9 using this information. Now what is V out when the thermistor is at 50 degrees Celsius? The resistance of the thermistor drops to 5. So it drops to 5. So let's do the math using potential divider. 12 divided by 12 plus 5 times the total EMF. We can find out our answer. 12 by 17 times 9 gives us an answer of 6.35. Okay? 37C. Last three. What is the conclusion from the alpha particle scattering experiment? We have three conclusions. Since most of the alpha particles pass straight through, the atom is mostly empty space. Since some of the alpha particles deflect by small angles, since there's a deflection, so the nucleus must be positive, and since very few particles deflect by a very large angle greater than 90 degree, so all the mass must actually be concentrated in a very small region. Protons and electrons have equal but opposite charges. That is clearly not a conclusion, guys. Have you watched Oppenheimer, by the way? It was an amazing movie. You should see it if you haven't already. Crazy movie. It makes it better if you know the scientists, so it's actually insane. I love the last part especially. Typical Christopher Nolan film, and the acting was amazing. Protons and electrons have equal but opposite charges, so yeah, we are going to... my tab is malfunctioning, give me one sec. Yeah, it's working now. So yeah, this is wrong. Protons have a much larger mass than electrons. We have nothing to do with electrons, okay? The nucleus contains most of the mass of the atom. Now this is correct. Do you remember I was saying that the nucleus is, all the mass of the atom is concentrated in a very small region? That region is the nucleus. And we had no idea that it contains neutrons. This was not concluded from the experiment, okay? This is wrong. So 38 is C. 39. Americium, I guess that's how it's said, is a radioactive nuclide used in smoke detectors. It undergoes alpha decay. So after alpha decay, we know that the alpha particle is a helium nucleus, and this all has to be conserved. So 241 minus 4 is actually 237, and 95 minus 2 is 93. So it's 237, 93, 39 is A. A top quark. So we have 6 quarks, right? Top, bottom, up, down, strange, charm. A top quark has a charge of plus 2 by 3. What is the charge of an anti-top quark? Okay, guys, so it is the same. It's just that all antiparticles have the opposite charge. So from plus 2 by 3, it's going to turn into minus 2 by 3. That is all. So guys, I hope you liked the video. I'm going to be dropping more content soon. So subscribe to the channel if you like the content, like the video. And yeah, please be sure to support the channel. You can also support me on Patreon if you guys want. It's patreon.com/CAIE papers solved. And I'd just like to shout out to my first patron and my only $15 patron right now, the highest tier. You get a shout out if you do that. It's Pearl. He's from East Africa. Is always going to be special to me for being my first patron, but you guys can join in my next video, and you also get to go for video requests, which I'm going to solve as soon as possible. Anyway, see you guys later. I'm gonna give you the links for the physics paper 1 playlist on the left hand side. That is physics paper 1 over here, and I'm gonna link the papers for the May-June 2022 paper 4, paper 1-2 up here, and February-March 2022 paper 1-2 down here. See you guys in the next one.